Welcome to the Silicon Learners. Today's topic is how a combinational logic is secretly behaves like a latch at a hardware level. At the simulation level, we assume all is good, but at the hardware level, it is not a behave like a combinational block. It is a secretly latch. So we will go at simulator and show this how it is done. So here I simply define a code of AND get to input AND get. Here is my always block. In sensitivity list I define as a whenever a changes means for example a goes 0 to 1, this block will be executes. Whenever a goes 1 to 0, this block will be executes. Means in any change of a, the always block will be executes. So let us add simulation configuration for this. Here is my objects. I have to add this in the waveform window. I add this. First of all, we give value of a equals to 1 and we will give value of b equals to 1. Now this is the AND get, so our output y will be 1 and 1 equals to 1. Okay, so here it is correct. Now here we will give value of b equals to 0, so we will force value of b equals to 0. Now 1 and 0 output have to 0, right? So let us see, and we are running it. So see this, here we make value of b equals to 0, but output still remains 1. Why? Let us see this. So we see this expression, we can say this it is a 2 input AND get, but in the sensitivity list we define as a only this block executes when changing in value of a, means whenever value of a will be changed, this block will be executed. Here we make a change in value of b, so this block is not executed, and this is called condition of latch infer. On the simulation and code we can see this AND get, but at the hardware level it is a latch condition. So how we will solve this? So in the sensitivity list we will make this star sign. What is this mean? So meaning of star means whenever any inputs with value changes, this block will be executed for any value of change. Okay, so let us see this how it will be behave. First we will compile it. Here we compile the code over. It is successfully compiled, and now we will observe the waveform of this. So you see this waveform, here we make change in b 1 to 0, and our output also changes to 0. 1 and 0 will gives output as a 0. So this is the reason why sensitivity list matters in the verilog, especially at the combinational level. When before this star sign we declare our sensitivity list as a, so it shows the whenever signal changes whenever a value of a changes, the always block will be executed, but it is not true for the combinational logic. So this is condition where the latch infers. So for a combinational block, if any input changes, the output also will be changes. Okay, so this is our correct combinational block. Now we are seeing another condition of latch infer. So see this, here we in the always block we define as a y equals to 1 bit 0, and our condition is if select means for any value of selects, when select value is 1 y equals to a assign. Okay, so uh, my question is in this code latch infers or not. So let us see in the waveform. Okay, here is our module, just add it. And we are just execute it. Let's add all the objects in the code. We are add it. Here is our input wire. Here is our input is select A and B. Okay, so let us see the output. First of all, we make value of select is 1, value of A equals to, let us make it 0, and value of, no, let us put value of A equals to 1. Okay, and value of B equals to 1. Okay, now according to our code logic, whenever any signal of change, whenever any input signal changes, this always block will be executes. Okay, so here we make select is 1 means this block will be executes. So let us see it. Here is y equals to 1 means y equals to A. Now let us make a select is 1. Select makes 0, and so the output, so our output is 0. Why it is goes 0, I explained from the code. So we make select equals to 0. For here we change input signal means always block will be executes. Now in the block it says condition select is 0 means this block will be not execute, and this is default, this is a default condition where here we see select is 0, so this will be executes. If we not define this default condition, our code give response as a latch. Why? Because we not declare else statement here. So for select equals to 0, in this case output will be holds previous value, not a new. But due to we already declared default condition, for if input doesn't match with this condition, the default output will be 0. Okay, the another case is, we see this case if else, we see these two case. First is if else case and second one is this sensitivity list. So what is the golden rules for combinational circuit is, whenever we declare the combinational block, first of all we have to declare sensitivity list. Now for the combinational logic, we know the for any input changes output will be instant change. So in the combinational block we will define with this sensitivity list. Okay, and whenever we declare combinational block as a condition, we have to declare the default condition, or if we use the if condition, then must need to declare else condition also. If we not apply these rules or in the code, the condition will be latch infers. Okay, and we will not we will not know the about condition in the simulation. We will know when the hardware synthesis happened in the synthesis tool. Okay, so for the get to know latch infers or not, we have to always observe the waveforms. So this is the golden rules. Thank you. In the next video we will go for FSM and see how the FSM declares and debug the FSM. Thank you.